One of the most valuable things you can learn as a developer is how to test your code. When done effectively, test-driven development can give you much more confidence in your code and prevent bugs from destroying your codebase in the future. In the last 3 videos, we wrote some JavaScript algorithms, but how do we know if that code actually works as intended? We did some general testing by console logging, but that's probably not sufficient in the real world. Luckily, modern JavaScript tooling makes testing pretty easy. In the root of our project here, I'm going to run npm init to create a package.json file for Node.js. That will allow us to run this command to install vtest, which is an extremely fast and easy to use testing tool. Once installed, let's head over to the package.json and add a script for test that calls the vtest command. In addition, we'll want to set the type to module on the package.json, which allows us to use ES imports in Node.js. Now, in the root of the same project, create a file called main.test.js. vtest will automatically detect any files that end in .test.js and run them whenever the code changes. At this point, we can open up the terminal and run npm test, which should result in a failing test because we haven't defined any yet. Let's go into our testing file and write our first test. At the top, we'll import expect and test from vtest, and then also import the sum function that we defined earlier in the course. And now we can use the test function to define our first test. The first argument is a string that defines the thing you're trying to test. Like in this case, we want to make sure that it finds the cumulative sum of an array. Now the second argument is a function that will run the actual code. However, we don't just run the code, we run it with an expectation, like we expect the function to return a certain value. Like in this case, we call our function with an array of sample data inside of expect, then we can chain additional methods to it called matchers that expect the value to be something specific. Like in this case, we're looking for the number 16. That's a very simple matcher, but there are all kinds of other options as well. Like you might test if a value is defined, if a function has been called, if it's greater than or less than, and so on. You can also have multiple expectations in a single test. Like we might also want to make sure that it works with negative numbers, so we write an additional expectation for that. Now the cool thing about automated testing is that it makes bug detection way faster. For example, if it's not returning the expected value, it will instantly tell us why in the console. In addition, it provides clear expectations for what our code is supposed to do. Like if we take a break for a few months and come back to this code to do some refactoring, we can be confident we're not screwing things up by running this test suite once again. At this point, I'll challenge you to write 2 more tests for the binary search and LRU cache that we wrote in previous lessons. By the end, you should have 3 passing tests in the console.